Integration. So in last class we discussed the introduction to definite integration, the basic difference between definite integrals and then indefinite integrals, and we discussed three different points related to definite integration. Okay, ఆ 3 points altogether meaning ఏంటి మనం నిన్న మాట్లాడుకుంది. ఫస్ట్ థింగ్ ఇస్ notations, second thing is geometrical meaning, and third one is some examples related to the geometrical meaning as well as the algebraic sense of this definite integration. Integral a to b f of x dx is defined as in the sense it means it represents a value or the area bounded by the curve y is equals to f of x axis and the lines x is equals to a and x is equals to b. See, ఈ ఫోర్ ఐటమ్స్ బౌండరీతో కొంత ఏరియా కనుక మనం బౌండ్ చేయగలిగితే ఆ ఏరియా మెజర్ చేయడం కోసం ఇంటిగ్రల్ ఏ టు బి ఎఫ్ ఆఫ్ ఎక్స్ డిఎక్స్ అనేది హెల్ప్ అవుతుంది. అండ్ దట్ ఇంటిగ్రల్ ఏ టు బి ఎఫ్ ఆఫ్ ఎక్స్ డిఎక్స్ వాల్యూ ఈజ్ ఈక్వల్స్ టు capital F of b minus f of a if derivative of this capital F is small f, and in the same way integration of this small f is capital F. Is it right? Now we are going to discuss some basic properties related to this definite integration. Okay, and one of the basic property is, see, integral a to b f of x dx is equals to integral a to b f of t dt. Both are same, right? We call it as change in variable property or dummy variable property. Here the variable is dummy. Okay, see, this variable won't affect the value of the integral. This variable won't affect the area bounded by the curve with x-axis and with the lines x is equals to a and x is equals to b. So don't bother about the variable. You just think about the function, whether the function is same or not. And you need to think about the limits, upper limit and the lower limit, okay, whether they are equal or not. Okay, so integral a to b f of x dx is equals to integral a to b f of t dt is equals to integral a to b f of z dz. All these are same. Okay, right? So we usually call this property as dummy variable property or changing variable property. This is one of the basic property, and all these are at the end is equals to f of b minus f of a if that capital F of x is the integration of small f of x, right? And the second thing is integral a to a f of x dx. See, what you say about integral a to a f of x dx, just we have b also as a, so f of b minus f of a. So if you replace b with a, f of a minus f of a is 0, right? So integral a to a f of x dx is what? 0. Okay, and the next thing is c, integral a to b f of x dx is equals to minus integral b to a f of x dx. Is it right or wrong? Just have a look. Integral a to b f of x dx is capital F of b minus f of a, whereas integral b to a f of x dx means capital F of this upper limit minus capital F of this lower value. So f of a minus f of b along with a minus sign. Okay, clearly these two are equal, right? And so we call these as the basic properties. So usually మనం ప్రాబ్లమ్స్ సాల్వ్ చేసేటప్పుడు ఎప్పుడైనా సరే ఈ లిమిట్స్ని కనుక మనం ఇంటర్చేంజ్ చేయాల్సిన అవసరం వస్తే దాని ఆటోమేటిక్గా ఒక మైనస్ మనం అటాచ్ చేయాల్సి ఉంటుంది. సో లిమిట్స్ ఇంటర్చేంజ్ అయితే వాల్యూ అనేది ఎఫెక్టెడ్ బై ఎ మైనస్. ఓకే, వేరియబుల్ మారితే ఇబ్బంది ఏం లేదు, వాల్యూ రిమైన్స్ సేమ్. But limits interchange చేస్తే value is affected by a minus sign, and if both the limits are equal then the value is equals to 0. Okay, all these are the very basic properties, and we mentioned these as under basic properties of definite integrals. And the third thing is d, integral a to b f of x dx is equals to integral a to c f of x dx plus integral c to b f of x dx. Integral a to b f of x dx is equals to integral a to c f of x dx plus integral c to b f of x dx. See, where you have that c, for c belongs to the interval a to b. So నిన్న మనం డిస్కస్ చేసిన విధంగా ఇంటిగ్రల్ a to b f of x dx అంటే ఏరియా బౌండెడ్ బై ద కర్వ్ బిట్వీన్ ద రీజియన్ a to b. So for suppose See, if this is x-axis, means y is equals to 0, and for suppose this is the curve y is equals to f of x, somewhere we have point A, somewhere we have point B. Actually integral a to b f of x dx is nothing but this total area. Okay, if you split this total interval at a point, say some c, calculate area between this area in this boundary as well calculate area in this boundary, and if you add these two areas then it is equals to integral a to b f of x dx only, right? Okay, so ఈ రెండింటిని యాడ్ చేస్తే టోటల్ ఏరియా జనరేట్ అవుతుంది. టోటల్ ఏరియా కావాలంటే a to b f of x dx, ఈ ఫస్ట్ ఏరియా కావాలంటే a to c f of x dx, సెకండ్ ఏరియా కావాలంటే c to b f of x dx. ఓకే, సో ఇట్లాంటి స్ప్లిట్టింగ్ ఒక్క c దగ్గరే కాదు, ఎన్ని సార్లు అయినా మనం స్ప్లిట్ చేయొచ్చు. అంటే వీ కెన్ ఎక్స్టెండ్ ఇట్, ఈ స్ప్లిట్టింగ్ ఆఫ్ ద ఏరియాని ఎక్స్టెండ్ చేయొచ్చు అవసరమైతే మనం. ఓకేనా, ఫస్ట్ ఆఫ్ ఆల్ అబ్జర్వ్ దిస్ అండ్ దెన్ థింక్ అబౌట్ దట్. అసలు స్ప్లిట్ చేయాల్సిన అవసరం ఎందుకు వస్తుంది మనకి, ఎలాంటి సందర్భాల్లో స్ప్లిట్ చేయాలి అనే దాని గురించి జస్ట్ ఒకసారి ఆలోచించండి. థింక్ అబౌట్ ఇట్. సో see, if you think is the splitting is necessary if the function is not defined at a point, if the function is not continuous at a point, if the function changes its definition at a point. See, for suppose we are going to calculate integral a to b f of x dx. In this interval a to b, in this closed interval a to b, in between this a and b, say for suppose at a point c, the behavior of the function is changing. Already we discussed about functions, limits, derivatives and everything we did. Okay, and వాటన్నిటిలో మనం ఏం చేసామంటే బేసిక్గా బిహేవియర్ ఆఫ్ ద ఫంక్షన్ అనలైజ్ చేసాం. ఇంక్రీజింగ్, డిక్రీజింగ్, కంటిన్యూస్, డిస్కంటిన్యూస్, లిమిట్స్, everything basically conveys us the basic behavior of the functions. For suppose if a function changes its behavior at a point in this interval, so at that point we need to split. Okay, so the splitting is the splitting is required if the given function is discontinuous, or if the function f is not defined, or if the function changes its definition, or if the function changes its definition. Okay, in the closed interval ab, then the splitting is required. For suppose if there are more number of points where the function is changing its behavior in the interval ab, then you need to split at each and every point. Okay, sometimes the splitting may be 2-3 సార్లు జరగచ్చు. ఇదే ఇంటర్వెల్లో a to c ఒకసారి, c to d ఒకసారి, అలా కూడా మనం స్ప్లిట్ చేయాల్సిన అవసరం రావచ్చు. సో అంత స్పేస్ లేదు కాబట్టి ఆలోచిస్తున్నాను. ఓకే, ఐఎమ్ గోయింగ్ టు erase this part and then I will explain for you that extension of this fourth point. Extension of fourth point ఏంటంటే, for suppose a less than c1 less than c2 less than and so on less than cn less than b. ఏంటి దీని మీనింగ్ ఏంటి అసలు? ఇన్ బిట్వీన్ దీస్ టూ a b, c1 c2 and so on cn అనే నెంబర్స్ ఉన్నాయి. అంటే if you think about a number line, so in between a b, c1 c2 cn are also numbers. Okay, now as per the requirement you need to split integral a to b f of x dx as integral a to c1 f of x dx plus integral c1 to c2 f of x dx plus integral c2 to c3 f of x dx. Like that, if we continue, integral cn to b f of x dx will give us the same value. Okay, same value అనేది ఓకే కదా. For suppose integral a to c f of x dx అంటే దీని వాల్యూ అవుతుంది f of b minus f of a నే కదా, f of c minus f of a. This is f of c minus f of a plus what is this value? f of b minus f of c. If you cancel out these two, we left with f of b minus f of a, which is this integral a to b f of x dx. So if you split, no problem, you will get same answer. Okay, but why the splitting is required? Splitting is required only if the function is discontinuous, if the function is not defined, if the function changes its definition in the closed interval ab, then at those points of c, usually we will split the integral according to the requirement of the problem. That's it. Okay, see, just observe this. These are the 4 basic properties of the definite integral. And after that, we have some more properties and we call them as an advanced properties of the definite integral. Okay, first of all have a look and I will discuss one by one.